and then talk a little bit more about the project. So we're a startup. We're about a year old, about 10 people. And what we're focused on is the manufacturing industry. And there's a kind of progression of manufacturing, this current wave they call smart manufacturing. And it's this Industry 4.0, they call it. It's the idea of cyber physical systems, right? So how do we take advantage of all the new technology to kind of translate all the physical activities in a factory or in operations into big data streams so that we can do analytics against? There's a bunch of companies in the space. You might hear about industrial Internet of Things, smart machines, robotics, all that. We're looking more broadly at the physical activities in the factory and trying to help our clients digitize them even if they don't have fancy new equipment. So when you're in a manufacturing environment, there's kind of three things that are occurring physically. There's machines and equipment, so the robotic arms, or it could be like one of our customers has a machine from the 1940s that makes coils. Guess what? That's not smart, right? It's not computerized. You can't get logs off of it. There's materials and products. Could be ingredients or components, the finished goods you're making. So there's kind of materials. And then, of course, people are a pretty big part of manufacturing operations, too. So as we kind of look at the space, what we challenge ourselves is saying, how do you translate all three of these physical elements into a cyber system that we can then go and do analytics on? And what we found is the first problem most companies are going to have is they don't know how to acquire the data. Even if you said, great, let's go siphon off the logs off that milling machine or off that robot and we'll scan the logs and do some analytics, they may not know how to do that, right? So we said, well, how do you make it so that anybody could do this? And so part of our solution is actually solving the data acquisition problem for the customers. Oh, Jan will show you our fancy props. We have cameras is a big part of what we do, and we'll talk a bit about our project, which is kind of centered around computer vision. Sensors, we have these little tags, which is using low energy Bluetooth beacons. If anyone's seen like a tile you can put on your keychain, it's the same technology, right? So you can stick those on assets that move around. People can wear them as a badge. And then we have what we call our outrigger. Atoll, by the way, is an island, so it's connecting your islands of information. And so we call our little devices an outrigger. It is actually a Raspberry Pi. And so we put these around the facility, and then those automatically connect to our cloud. So we're actually doing the data acquisition as well as then moving all the data back to the cloud where we actually do the analytics. And then we're able to actually give people the dashboards, et cetera, so they can actually act on the information. So what we call this is kind of composite analytics. We're looking at all three of the physical activities going on: people, material and products, machines and equipment. And what we do is we kind of use this idea of time and place correlation. So we always know the time, everything has a timestamp, but we also know the physical place in the facility where it happened. And now we're able to kind of correlate all this information into a common analytic. We can kind of keep layering information on top of itself to make it smarter and smarter and smarter. So we could get multiple data points around the same operation and use that to provide better insights. And I'll show you a quick example of something we're doing. So one of our customers right now is a machine shop in Fremont. And about a 300,000 square foot facility, and we're focusing on one department right now. And what we've got is we're tracking the movement of 18 machinists, so 18 people. And then the main subject of interest here is these precision mills. These are these very expensive mills that make complex metal parts. And what we've got is a combination of the beacons and the cameras. And actually, there's a camera in this. It's a Raspberry Pi camera. They're nice and small. And so here's an example of what we're doing. So this is literally the imagery that we're capturing. For every image, there's three things we're looking at. Each one is looking at two machines. So in each one, we're looking at two different milling machines. We try to figure out where the people are, because that tells us something. We try to look at the door position, whether it's open or closed. Again, that's informative in terms of what's happening in the operations. And then in a lot of factories, there are lights, status lights on the equipment that are there for humans to figure out what's going on. We're like, well, great, we'll do the same thing. I can pretend like I'm standing there and keep track of what's happening. And so what we do is we turn these sources of information into an analytic that actually translates the information for the people that run the factory, and it means something to them. Because if they were standing there looking at this scene, they would understand what's happening, right? And a lot of manufacturing today is managed by, they call it management by wandering around. Literally, it's intended that supervisors walk around the facility to keep track of what's happening. We're basically like, hey, what if we could do that without having to wander around? Our stuff's there. We never blink. We're constantly monitoring. What would happen if you could turn all that rich information into analytics? And then the result set comes out. We show them like this. Doesn't look very exciting, but if you're the person who runs it, it means something. Okay, there's a break. I know it's scheduled then. Oh, good news, the machine was running. That's good, because normally the machines don't run on the break. Uh-oh. Well, here was a big period of time. I had 45 minutes where the machine wasn't running. I need to run that machine to make money. So there's an opportunity to add 45 minutes of time where I'm producing parts if I could get my workers to better schedule their time and start a job before they go on a break. And then here's one where, oh my gosh, I had 2 hours where the door was open, the machinist wasn't standing on the station. That's 2 hours of capacity I lost. And this is the kind of stuff they're looking for because the company, to make money, needs to produce parts. And they can't produce parts if they're not milling parts, right? So what's fun about this is we use 2 different layers. These bottom 3 rows are actually using the machine vision we saw on the last slide. Up top, we're actually using this tracker to detect where they are. And what you see up top is they were in the area where the mills are, but they weren't at this mill. The red line is telling us there was a person physically standing where we consider them operating the machine. So I know they were in the area, and we know they were probably working on another mill. Well, this means something the supervisor has to figure out, well, how do I let them know? Maybe I need a notification system to alert them when this one goes idle. They could take a few minutes, come over, load a job, and go back to the other one. So they're looking for ways to improve their operations, but without this data collected, they're basically limited to what the people can see when they walk around. So this brings a whole nother level of data for them to kind of work with. There's that. So I'll hand it over to Jan.
All right. So as Rob was saying, we're combining a bunch of different types of information to give insights to our customers. And the challenge is around collecting that information and then analyzing it and then making it understandable to our customers is really what Atology is all about. So for us, on the edge at our customer's site, we have to build a reliable and flexible system that's easy for our customers to install and replace parts if things break down. And the challenge of doing that and having things running consistently and reliably is significant. But once you have that data collection in place, then the next level of challenge comes around, and it's all about understanding what's in the images and figuring out, you know, what are the important signals that are coming out of the data that we're collecting. And so one of the things that we're really interested in doing is collecting this large data set of images coming from our manufacturing partners and turning it into something that's a little bit like the ImageNet collection, so that neural networks can really grab all of the interesting information out of these images very efficiently. The other thing that we're seeing is really exciting about this is that there are really an infinite number of different things we can look at, but there's certain patterns that we're starting to identify at our customers. And what we want to do is repeatably take some of those systems that we're setting up and turning them into a set of sort of generic machine vision techniques that we can perhaps even move to the Raspberry Pis as we figure out how to compute them efficiently. And then last but not least, we want to take all of the information we've collected and present it in an intelligent way for our customers, so that a line manager can use it, for example, to figure out how they can do better on the production for the next day. So we have to be able to do that, and we have to be able to do it at scale, because these are some pretty complex SQL queries. And if you're running, you know, thousands, tens of thousands, hundreds of thousands of these, you have to know how to run them efficiently. Should I keep on this one? All right. So the research project that we're interested in sort of pitching to you guys is detection of contaminants. So it turns out that, you know, if you go to the supermarket, more and more of the lettuce you buy are in plastic bags. Well, this type of distribution is becoming common for restaurants as well. You don't want necessarily to have to do all of the washing of your lettuce, et cetera, or preparation, but receive something that's almost ready to go. Well, so there are actually food packaging plants that receive lettuce that's been, you know, or spinach or greens that have been picked from the farms, and have to cool them down and then, you know, rinse them, dry them, and package them at a very fast rate. So up to like 1 million pounds of lettuce a day in one packaging plant. So the difficulty there is that a lot of this stuff dirt or plastic or stuff can come together with the lettuce and make it all the way even to the packaging part of the system. And so our goal here is to catch a stream of all of the lettuce as it passes through on the conveyor belt and identify things like plastics and dirt and perhaps even animal parts, heaven forbid, that might show up in this stream. So here's an example of some of our first experiments, which is simply doing color matching. And so by identifying all of with spinach, it's fairly easy because the spinach leaf color is fairly uniform. By identifying the background color, we're able to abstract out that part and find where the candies are, the candy wrappers. By the way, some of these colors are representative of the plastics that you might see as a contaminant in this plant. Just to give you an idea of, this is sort of the speed at which things are moving around in the plant. These lettuces go up a conveyor belt 3 stories high, and then they drop down and get sorted and filtered out and packaged into like 1 to 5 pound bags. And there's our first camera in the facility checking for them. So here, in our first example here, basically one of the things that we've had to discover is that lighting matters. If there's too much light on it, the spinach gets washed out and it actually reduces our accuracy. So one of the things that we have to do is actually tune the physical parameters of our data collection so that we can do a better job. But once we've done that, there's a whole bunch of other kinds of things we can do in software to improve the likelihood that we catch the contaminants. And so we do a bunch of filtering to try and see what are the best ways to highlight the information that we really want to get. Okay. So I think I've mentioned a number of the activities that we're looking to do during the course of 2018. Analyzing the captured imagery, figuring out how we can parcel out some of the work between what we're doing in the cloud and what we can already do on the Raspberry Pi. We have to do things like figure out what's the best set of physical settings for our devices to do high quality data capture, and how we can get a reliable and resilient system in place by understanding where's the best placement of things, what's the best type of equipment to use. It turns out that things as simple as a USB cable can determine whether your Raspberry Pi crashes more frequently or not. So if your USB cable's too long, well, maybe you're going to get less reliability. And then finally, we want to figure out how to take the commonalities between a lot of the data that we're collecting between customers and turn them into more generic algorithms. So there's a lot of things to do. These are problems that have real impact for real businesses. So it's kind of interesting to see that work that you do might have a direct impact very quickly on the output or productivity of a company. So that it can have that exciting factor as well. And that's it. So anyway, if you have questions, you can reach out to us. Tony just arrived. He's actually the person who made the contact here to have this happen. Yeah. All right. So thank you very much. Yes. So there's lots of problems we have to solve, and the sorting spinach problem is one of them. But we're happy to work with creative people on all of the problems that we're doing. So in composite analytics, basically, what we want to do is do a little bit better with producing, those charts that highlight the information that people in our manufacturing partners can really understand what's going on. So how to improve the quality of those analytics, and then improve the queries themselves that generate them. So yes.
Just as an aside, so this customer that we're looking to do the research project with, the primary thing we're doing for them is actually monitoring physical operations behind the facility. We're watching, back a little bit, watching the trucks come through the yard. There's a whole set of operations that happen outside. They cool down the lettuce and then it goes in, actually. So even in this case, eventually trying to tie what we're finding with contaminants back to where did it come from, what truck delivered it, et cetera. We even have some opportunities at this particular customer that we're working with for this research project to do some of the correlation with other activities right there. But this particular thing they asked for help with was kind of ahead of our product roadmap, and so we've kind of turned it into a research project. Any other questions? Yeah. Yeah, absolutely. Yeah, we've got 5 running now, and pretty consistently, it's very eye-opening for them. We'll have them say, "Oh, here's how something works," and we say, "Great, let's put our instrumentation in," and we're totally, unbiased, right? It's just observing what's happening. There's no influence to what it collects, and pretty consistently, as soon as we show what we've collected and we kind of show what we've observed about the process and cycle times and what's happening, every time we've had a big surprise right away from people who literally have been running these operations for years, and it brings them brand new insights. So they're finding it very useful to better understand what's actually happening today so that they can start figuring out how to make it better. And it's, in some cases, just causing them to start rethinking how they've been doing stuff. They're like, well, why do I have my operators spend time writing something down or tracking this or doing this when you're able to see it? They don't have to waste time doing that, and they're wrong anyway, right? Like when they capture it and stuff. So very consistently, people have been pretty excited about the insights we're able to give them very quickly, too. The installations take about an hour, and it's usually about a week before we're producing the first set of analytics for them after we get the models configured and trained. Yes?
Have you observed any changes in the social interaction of the workforce where this vision analytic has been deployed? I'm thinking reminiscently of Deming's famous time and motion studies that really was the precursor, as the way I see it historically. And this is something, perhaps I'm not characterizing it correctly, but as a next generation of that. And I just wonder if there are any anecdotal feedback regarding the sociology of worker interactions from the 5 companies that you deploy at.
It's a great question, actually. So, one of the things that came up with them with the first customers was like, wait a minute, there's going to be a camera watching what I'm doing. I don't know if you noticed, one of the things we do to kind of handle that is point out the goal is not to spy on Lucy or Fred, right? I mean, it's intended to help people better understand operations. And so we very deliberately focus on obfuscating the people. Our goal is not to say what that person's doing. We're trying to understand human-machine interaction and how it relates to a process. And we had some concerns up front. One of the first factories we went into was a union shop, and they had to tell the union we're going to be putting cameras in to monitor operations. A couple of questions in the first meeting, and we checked in the week afterwards. We're like, have people asked about it again? They're like, no. And so there's this thing called the Hawthorne effect, which comes from time and motion studies, and in industrial engineering literally used to be with a stopwatch, and I'd watch what you're doing, and I'd watch what you're doing, and I'd write it down on a piece of paper, and that's how you studied a process, kind of the current process. This kind of fades into the background pretty quickly. It's amazing. But what they learned is this Hawthorne effect is that when people know they're being studied, they behave differently. So it's almost impossible. It's like the experiment itself ruins the process, right? And so it's in the past, it's almost been literally impossible to get an actual representation of what the process is. Because this is so unobtrusive, these cameras are up 18 feet in the ceiling, no one really sees them. It's so fades into the background, people kind of forget about it. And suddenly people are just acting the way they act, and it kind of avoids the problem. And then the other thing that we advocate for the management to do with the data to avoid some of these concerns around the social experiment is we're encouraging them to actually apply almost software engineering techniques. So one of our clients, we don't have the example here, the testing operations, they're an electronics manufacturer. It's a big bottleneck, everything gets stuck there. It's a very complicated electronic product. And they use the data we collect around the testing operations. They literally run a stand-up meeting with the people that do the testing each morning and treat it like almost a scrum process, right? And we're like, you need to empower your people to improve the process. To us, smart manufacturing, the smartest thing in the manufacturing facility are the people. So how do you get them engaged in making the process better? Whereas a lot of other companies are going, give me the logs off a robot, and I'll tell the robot how to be better. And so we get them engaging the workers with the data, and we think that helps a lot too. And as we've gone back out to some of these facilities, actually this one, when we go out for visits occasionally, even the workers are like, hey, this device is hanging down, is that okay? I mean, they're actually kind of interested in it. And I think that the fact that it's kind of cool and new in an old-fashioned manufacturing environment, so far we've seen the workers actually think it's pretty neat, and they almost like in participating in it, which we were very worried about originally. We thought they might just see it as spying, but the way that they're using the technology, the way they're getting engaged, and the fact that it's kind of cool, so far has actually been a positive. We've been pleasantly surprised.
So in general, then, you guys are completely oblivious to Google surveilling you on the web, right? All right, thank you guys very much. Enjoyed the talk.